So our next step is to disassemble our gear shaft. So I've kind of cleaned up most of the other transmission parts, so I haven't really started looking at everything. To disassemble the input shaft, we need to undo this nut. These are a one-time use, even though the last guy that peened it, you can see they tried to reuse it. And we also need a special tool to hold the input shaft while we undo this nut. So I've got my special tool mounted right here, and it is a spline tool that will support that input shaft. So now I can undo that nut. So once I've got the nut undone, I'm just going to go ahead and slide it off. And as I said, this one you can see here where it's been peened. So this is a discard. So this whole gear set is held on by these two bearings, other than the nut that retains them. So what I need to do is put this into the press, and I'm going to press this whole gear set up just until it pops these two bearings off. So when I set this in the press, I'm going to locate on this bottom gear set. I'm going to push the whole lot up in one piece, and it shouldn't take a lot of force to do this. So I'm just holding that shaft so it doesn't drop out all the way. And then we can see I've got the bearings are free. And now the rest of the gear set can move pretty easily up and down. So we're going to go put it on the bench. So now to disassemble, I'm just going to slide off the bearings. And I always like to lay everything out in order if they came off. And we're going to slide our gears off. Slider. And that is our disassembled input shaft. Now I got to wash everything up, clean and inspect. So now I've cleaned and washed everything up, I can go ahead and do my inspections. When I'm looking at my synchros, for example, what I'm looking for is, this is third gear, this is the primary issue. You can see how this synchro material is all breaking off. The way these work, these are like a mini drum brake. We'll disassemble this in a minute and I'll show you what's inside. But as our slider comes over, this gear is spinning. This is a friction material that's going to slide against our slider and slow this gear down so it synchronizes and then clicks into gear. The other thing I'm looking at is the wear on the dog teeth. And the dog teeth are right here. They will mesh with these dog teeth. And on third gear, what we're seeing is how rounded the teeth are. Now these ones aren't as bad as I have seen, but they definitely are rounded off. When we compare them to fourth gear, we can see how much sharper that V point is. So if I was to go ahead and leave this, what could possibly happen back into the car is when I'm selecting that gear, the two dog teeth could get jammed against each other, and that means you'd have to take it out of gear and then try and re-engage again, as they wouldn't mesh properly. So the other things that I'm looking for when I'm doing my inspection, other than synchro wear, is wear or damage to the teeth. Now these are really strong on the physical gears. Generally you have very little problems unless the transmission has been run dry of oil, in which case this will be burnt and it'll usually be black. If you ever do need to change gears, they need to be changed as a set. So if I needed to replace third gear, I would need to replace the corresponding gear on the pinion shaft as well. When it comes to the input shaft, there's a couple of things I'm looking for there. Excessive wear on the input shaft seal right here, and it's amazing how a piece of rubber can eat into a piece of steel, but it can. So if this is excessive, then I'm probably going to end up having to replace it. This one's not too bad. One thing that you do have to bear in mind is that the input shaft does have a gear on it. So if this shaft needs to be replaced, then the matching gear to this will also need to be replaced. When it comes down to numbers, so every gear will be numbered and it'll be etched with an electric pencil. Its matching gear will have the same number. Next thing that I'm going to be looking at is the roller bearings. Now typically I only replace the needle cages when I replace a gear, or unless something has gone wrong. So on this particular transmission, for example, this is my 5th gear needle cage. You can see that cage is actually split right there. It is supposed to be a one-piece deal, and the roller fell out when I slid the whole thing off. So there's the roller that came out of it. So I'm going to replace this one just because that cage has failed. In general though, typically these only get replaced with the gears. When it comes to the main bearings, so these are the main input shaft bearings. This is going to be the front one. This is what's held by this plate. This is going to support the shaft and control some of the gear depths. This bearing is a 4-point annular, and basically what I'm trying to do is feel if there is any issues. A lot of the time you have to have driven the transmission in the vehicle and actually diagnosed a bearing noise to know exactly if these bearings have failed. One of the things we can do is we can look at the amount of wear in the race. Now this is the bearing that was in the front transmission case, and this is the bearing that was mounted on the input shaft. These are about 50% worn, and the reason why I say that is by the amount of wear that I have in here. There's no aggressive pitting or damaged per se, but I can see it's worn in, and when I run my finger over it, it's got kind of a rough feel to it. Now, with this bearing in here, I could put this back into the transmission and it would still run at the current noise levels that it had. There's no obvious signs of pitting right here, and the bearing doesn't feel particularly horrible. So a lot of it comes down to the decision that you make as to how long you intend to keep the car, what your budget is, whether you're bringing the transmission back to an as new condition or whether you're just fixing like a worn synchro so you can put it back into service. Okay, to pull our synchros apart and change that synchro band, I'm going to use a pair of circlip pliers, and this is basically a large circlip, and sometimes they will kind of fight you because as you expand them they tend to want to twist and expand. So what I've done is I popped one side up and out, and then I can kind of rotate this out. The other thing we want to look at is the amount of wear that's going on in here. And if it's significantly worn, sometimes we'll need to replace these, but generally they're fairly good. So when we look in, this is our actual synchro band. These are going to be our 2 anchor blocks here and here, and these are going to be energizer bands. What's going to happen is when I try and select this gear, is this synchro ring is actually going to rotate up against these anchor blocks like that. As pressure is put on this anchor block, it will push out and it will actually flex out against this synchro band, holding it out essentially and helping to apply pressure to the slider. And that's basically how they're going to work. As far as parts in here, synchro, we can see this one is our 3rd gear and it's definitely worn. It's got a lot of polish to it. We can see the other side right here still has a fairly rough texture to it. The next thing we want to look at, the main things inside here, is the wear points on the anchor blocks. They should be clean, no big grooving, and the same with our energizer springs. We're just looking to make sure there's no pitting or any obvious damage. These are fairly robust and generally can be reused. So now I've got the old synchro off. I'm going to reassemble with a new synchro, and we can see the difference right here with the material. This is the synchro off of 4th gear, which wasn't too horrible, but what we're looking at are these polish marks where the abrasive part of the synchro is worn. But to reassemble, I've washed all of my parts, I've inspected all of the helper springs, so I'm just going to start by installing the anchor block, which is going to locate on this little cutout, my 2 energizers, and the top activator block. Then with the synchro, I'm going to just lay it on, and I need to compress it into those dog teeth. And this is going to move, so it doesn't have to be perfectly aligned, and that's normal. Then we're going to take our circlip, and with the circlip what I'll do is I need to hold that synchro ring down, so I'll kind of start one edge similar to how I took it off, and then use my snap ring pliers and wind it around. Okay. Once I'm snapped in, the gear will rattle, which is normal. That's all the pieces. The other thing I want to make sure is my circlip isn't exposed in this area. So I'm just going to wind it around and give it a little bit more distance. Put it off to the side. And then I can check that this will rotate and lock up. That means that everything is connecting inside and binding up on those energizer rings. So in 3rd gear, we've got wear on the dog teeth, and to see the difference, you can see the new part is nice sharp, and probably holding it on the end is going to be a better way. They're nice sharp V shape. That means when it aligns with our shift sleeve, it will automatically drop to one side or the other and should not balk or get stuck and have to try and re-engage. To replace these, we do need some special tools. We need a special fixture that's going to clamp on to that dog ring, and we're going to use the press. We're going to press the existing gear out, clean this, press it on. These are a very tight fit. Porsche does not actually offer this as a factory part. It is an aftermarket part. Porsche says when these parts are worn, you need to replace the complete gear set, but that's about a $3,000 to $4,000 option versus buying this for $150, $180. So to remove our dog teeth, I'm going to use a special tool that will clamp onto the old ring and allow us, it just has a groove right here. There's a groove on that dog ring. So I'm just going to put this on, tighten it up, and that's going to allow us to push out the gear from the dog teeth. So this one's going to take a lot of load. I've got a piece of steel underneath to catch our gear, and I've got my press plate so I'm spaced out. Also, I've made sure inside that my gear is free so it's not going to hit anything on the way through. And this will usually make a pretty good pop when these let go. Except for this one that just popped right off. So I've just taken off the old dog tooth. The way to install is I'm going to take my new one. I need to wash it first though, and I'm going to install it back into here. What this does is it holds this whole top ring, so if I just tried to press it straight on to here like so, I run the risk of damaging this top plate. So if you put it back into the tool, that'll stop it from getting damaged, and then we'll put it back in the press and press everything back together. So what I've got to do now is I've got my synchro mounted in my fixture. I got to make sure my gear lines up with the little square cutouts in there, which can sometimes be a little bit of a challenge. So I usually look for a little bit of engagement. Then I'm going to bring in my mandrel, which is going to allow me to press on the gear without damaging it. The other thing, I want to make sure that it goes in straight. So I want to be straight underneath the ram so that it pushes evenly all the way down. I'm just going to use a light seating pressure just to make sure it's seated hard up against that gear, and then release. Okay, all we got to do now is take the fixture off and the gear's ready to have the synchro put back onto it. So the same as fourth gear, just going to assemble my anchor blocks, my two energizer springs, making sure they're all sitting in, new synchro ring, and just want to compress that synchro ring into the dog teeth so it holds down against them. We're going to take our snap ring, start it on one edge, and then work it away around. Same thing, I'm going to make sure that everything moves, and it should be fairly firm, and when I shake it I should be able to hear the parts loose in there, and that's it. So now I've replaced all of the parts in third gear, I've replaced the fourth gear synchro ring. It's time to reassemble the input shaft. Very important that when you reassemble this that the shaft is completely clean and dry of oil, especially on the surfaces where they contact. So I'm just going to assemble it in the reverse way as we took it apart. Slide on our spacer. Next is going to be a fixed gear. Press it all the way down. Our thrust washer. Then this is our inner race and bearing for our third gear. Slide that on, followed by our actual third gear. And I just want to make sure it's not hitting anything or binding. Next is going to be our spider. Slide that on all the way. Now, whenever I replace dog teeth, this is our slider ring. This is the old one. Because this ring has been grinding against those old dog teeth, I'm not going to reuse the original, and I'm going to put a new one on. So that's then going to slide on and just sit. Fourth gear. And sometimes you just got to spin these to get them to line up because the clearances are nice and tight, just like that. Followed by the needle bearing. Fourth gear, and we can see how the synchros are facing each other. If you put them on backwards, obviously they're not going to be able to select. And then finally our thrust washer. That's going to seat and hold that bearing in place. So I've got our new input shaft bearings that we're going to install. This is our annular 4-point bearing that we're going to install this first, followed by the regular support bearing. So these are the ones that we're replacing. As I said before, when we inspected these, they're about 50% worn, judging by the amount of wear on the race that we can see. And we're changing them just to ensure that everything is 100% when it goes back into the car. So the easiest way to install these bearings is to heat them. So I've got my hot air gun, a bit of wire, my welding gloves, just so I can handle it to slide it onto that shaft. So I'm just going to heat this race up and then install it. Not hot enough yet. So a quick way to know if your pots are hot enough is you spit on them slightly and it just dances off. It should be hot enough. If it doesn't bounce right off, then the pots need a little more heat. Slide that on all the way and seat it. Next we're going to set the bearing in our retainer. This is going to slide on and sit there. And because this is a 4-point annular bearing, I've got to heat the next rod and slide it on. Hold that in place. So the last thing I'm going to do is put my new input shaft nut. These come with Loctite in them, so they can be a little bit of a pain to screw down. And once I've got it just so it's contacting, I'm going to use my torque wrench, 1/2 inch drive, and tighten it to 160 Newton meters. Okay, before I peen the locking part of the nut, I need to put my rear bearing on, set it up in a set of V-blocks, and just check my run out on the shaft. If there is any deflection there, we can correct some of it. If it is past its maximum specs, then we'll have to pull things apart and see what's going on with the shaft. So we've got our back bearing on. Just going to set the race up and set up my V-blocks and make sure the shaft doesn't have an excessive run out. So our maximum run out should be within 0.1 of a millimeter. Looks like we're sitting right around 0.08. There's some slight movement there. It's just not quite making that 0.1, so within usable ranges. I'm going to go ahead, sit it back in my block and peen my nut, and then the input shaft is complete, ready to be installed. I'm just going to take my center pop and peen in. And that's about all it needs right there.